Hey, college algebra kids. Today we're looking at writing equations of lines, writing equations of linear functions. So notes out for section 3.1, part 1. And here we go. In yesterday's video, we looked at taking an equation and graphing it. So today we're looking at the reverse. Given a graph, how do we write the equation? We're going to look at three forms for the equation of a line. The first is good old slope-intercept, y equals mx plus b. Recall where m is the slope and b is the y-intercept. Now we're always going to write that so that the x term is first, so that the number comes behind. Example 1 then asks us to look at given a line on a graph. We want to graph the equation of the line through 0, -2 with a slope of 2. So there's a couple things. We already know the slope. The slope is 2. Sorry, we're just looking at A, not B. So what do we know? Well, we know the slope is 2. We have an ordered pair. Every ordered pair is x, y. And so x has to be 0 and y has to be -6. Well, for our equation, we know everything except b. Our equation is y equals mx plus b. And so we're just going to plug in y, plug in m, plug in x to find b. Y is -6. Again, we got that from our ordered pair. The slope is 2, and x is 0. And we're going to leave plus b as our variable. And we're going to solve. 2 times 0 cancels. Therefore, b has to be -6. So we know the slope is 2. We know the y-intercept is -6. All that's left is to go back and plug into the original equation, y equals 2x minus 6. There's our m. There's our b. So there's our equation. So if we're given the parts, we can plug into slope-intercept to find the missing pieces. Letter B, what if we have a line? Well, on our line, we have 2 points. So we're going to need 2 things. We're going to need slope and y-intercept. Now, some of you may remember all the tricks for slope and y-intercept, and you're certainly welcome to use those. But we're going to need to find the slope. And there's 2 ways to find slope. Right? One way to find slope is to use our rise and run. So from this point to this point, going always from left to right, how am I rising and how am I running? Well, my rise is actually going down. So my rise is down 2. And my run is going across 3. So my slope has to be -2/3. How else could I do that? Well, I can also do that by plugging in points. This point is 0, 3. This point is 3, 1. So using our slope formula, subtract the y's. That would be 3 minus 1 over 0 minus 3. What does that give me? Well, that also gives me -2/3. So there's our 2 methods for finding slope. You can use either one, whichever one makes more sense to you, or whichever one the problem calls for. So there's our slope. We already know points. We picked out points. So we can go back and use y equals mx plus b. Let's say we use our 3, 1 point here. Remember, the first number is x. Second number is y. We're going to plug in. So 1 is equal to our slope, which was -2/3, times x, which is 3, to find the b value. Multiply that. The 3's cancel. We're left with 1 equals -2 plus b. Add the 2 both sides. b is 3. Therefore, there's our y-intercept. There's our slope. We have enough for slope-intercept. Y equals -2/3 x plus 3. Now, what's the shortcut? Well, the shortcut is, remember, the b is the y-intercept. Where did we cross the y-axis? That was at 3. So 3 was actually the y-intercept. If you remember that shortcut, you can use that as well. Example 2, find the slope and y-intercept of the line, 3x minus 2y equals 5. So now we're given an equation. This is actually in standard form. How do we find the slope and y-intercept? Well, the key here is we have to solve for y. Solve for y. So we're going to take our equation, 3x minus 2y equal 5. To solve for y, the first thing we want to do is opposite the x term. So we're going to subtract a 3x to both sides. So we're going to have negative 2y equals negative 3x plus 5. We're going to always put that x term first so that this is in descending order by powers, what later we'll call standard form. And then we want to divide the coefficient. So we're going to divide by negative 2. Therefore, y is 3/2 x plus negative 2.5. Therefore, what's the slope? And we do want to come back and identify. The slope is the number in front of x. That was our 3/2. We will always leave that as an improper fraction or as a fraction if it comes up to be a fraction. And b is negative 2.5. You can also answer as negative 5/2 as well. That would be the same. We can also graph then using y-intercept form. And this is the graphing method that we'll use most often. To graph using slope-intercept form, first we want to solve our equation for y if it's not already. We want to plot the y-intercept using b, and that point has to always be 0, b. It's got to be on the y-axis, so the x has to be 0. So we're always up and down the y-intercept value. Then we're using rise and run to plot points, and we draw the line. Let's practice a couple of those using slope-intercept method. Now, could you always make a table? Yes. Can you check all these by putting them on your graphing calculator? Yes. All right, but we want to just get to the habit where we can graph these without doing any of that. So here, our slope-intercept is b. That means the point that we're crossing the y-axis has to be at 0, 1. So there's our first point. Again, all of these are linear equations, so they all have to be straight lines. And then we're going to use our slope. Our slope is, again, rise over run, which it already tells us is 2 over 3. There's how we're going to get our points. So from our y-intercept that we already found using the 1, we're going to use rise and run, which is up 2 over 3. Now, how do I know this is up 2 over 3? Because these are always positive, and we're always going to go to the right. So my positive and negative is always going to be up and down. We're always going to the right until we put points in the other direction. Let me show you how this works. So we're up 2, right 3. So I'm going to go up 2 spaces, right 3 spaces. There's my next point. I can do the same thing, up 2, right 3. There's my next point. It'd be nice to do some points in the opposite direction. What's the opposite? Well, instead of going up 2, I'm going to go down 2. Instead of going right 3, I'm going to go left 3. We can do the same thing going in the opposite direction. And there's my equation. We'll put some nice pretty arrows on there. There's the equation of the line. A couple more. Letter A, the first thing we're going to note is this is not solved for y. This is actually in standard form. To solve for y, we're going to opposite the x term first. So now we have negative 4y is equal to negative 3x minus 8. Now we're going to divide by the coefficient. And we're going to see what we're left with. Negative 3 over negative 4, the negatives cancel to be positive 3/4 x. Negative 8 divided by negative 2 becomes plus 2. My y-intercept then is at 0, 2. So we're up 2 on the y-axis. Our slope is now 3/4. So our rise and run takes us up 3, right 4. No more points will fit on here. If you're doing your homework, you could probably get one more on there. Down 3 and left 4. And so there's the equation of our line. Again, we like to have about at least 3 points or so, just so you get the pattern. Same thing for letter B. First thing we want to do is solve for y. We're going to move that 5x to the other side. Shortcut, it just changes sign. So there's negative 5x minus 2. Divide everything by 2. Here's negative 5/2 x. Negative 2 divided by 2 is minus 1. Now we're going to plot our b. Our b is at 0, negative 1. Y-intercept first. Slope then is negative 5/2. So now I'm dropping 5. 1, 2, 3, 4, 5. And I'm right 2, which is right there. Opposite of that, instead of dropping 5, I'm going up 5 and left 2. And there's that equation. So graphing lines using slope-intercept method. Y-intercept first. We'll solve for y first. Slope-intercept, find that y-intercept, and then use your slope to get points to draw the line. Next up is standard form. This is our second form of a linear equation. And this is the form that we were just solving with. Standard form says, or is the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. And in fact, we want a, b, and c to be integers instead of real numbers. We want a, b, and c to be integers. So let's look at an example. So we've just converted from standard form to y-intercept. Now we're going to go backwards. So we're going to take this equation that's in y-intercept form and change it back into standard form. So we want to go to standard form. How are we going to do that? Well, like any equation that we saw previously in this chapter, what do we want to do first? Well, we want to clear the fractions. So step 1 is clear fractions. To do that, we're going to multiply by the least common multiple. Here, the least common multiple is 4. That's going to give us 4y equals 2x minus 3. And then what we want to do, we want to get x and y on the same side. To get the x and the y on the same side, the 2x needs to move back to the front. So we'll subtract the 2x to both sides. So this is negative 2x plus 4y equals negative 3. Now we're back to standard form instead of slope-intercept form. Clear fractions, move the x back. We're basically just oppositing the steps that we did for slope-intercept. One more thing to note, if we ever wanted them, the a value is the value in front of x, that's negative 2. The b value is the value in front of y, that's 4. The c value would be negative 3. You don't have to jot those down, but if we ever need those, that's where they came from. Checkpoint 4, write in standard form using only integers and positive coefficients for x. Go ahead and pause the video, see if you can do a and b, and then we'll check your answers. And here we go. Letter A, the first thing we want to do is clear the fraction. So if we have y equals 1/3 x minus 2, we're going to clear it by multiplying by 3. That gives us 3y equals 1/3 of 3 is 1. That cancels. Minus 6. We want the x and the y to be on the same side, so we're going to subtract an x both sides. We always do want this to go in order. So this is negative x plus 3y equals negative 6. The question also said use a positive coefficient for x. I just realized it said that. To get x to be a positive, we're going to multiply by negative 1. That's going to change the signs. So we get x minus 3y equals 6. Basically what that does is that just flips all of the signs. That would be the shortcut. So there's our equation. Letter B, we have distributive property. We're going to do distributive property first. So y minus 5 is equal to 1/2 x plus 3/2. You have some choices here. You can either go ahead and combine like terms, or you can clear fractions first. It'll all be the same at the end, but we did want to do that distributive property first. I'm going to go ahead and clear fractions. So this gives us 2y minus 10 equals x plus 3. Now we can move stuff around. I'm going to subtract the x back to the front. I'm going to add the 10 to the back side, and therefore we get negative x plus 2y equals 13. Again, we want to have a positive x coefficient, so we're going to multiply this by negative 1. That flips all the signs, so x minus 2y equals negative 13. Again, going to standard form. Our last form of a linear equation is point-slope form. The equation in the form y minus y1 equals m times x minus x1. Example 5 says find an equation of a line through a point. Now, why do we use this equation? We use this equation whenever we're given a point and a slope. Whenever we get a point and a slope, we're going to use point-slope form. Example 5 says an equation for the line through negative 2, 5 with a slope of negative 3 and solve it for y. So we're just going to plug in to our formula, y minus y1 equals m x minus x1. Well, what do we know? We know slope is -3 because it tells us slope is -3. We know the x1 coordinate has to be -2, and we know the y1 coordinate has to be 5. And that just, again, came from our ordered pair. So there's all of our pieces. We're going to plug that in. And here we go. So y minus the y coordinate, which is 5, is equal to our slope, which is -3, times x minus the x coordinate. Note minus and -2. The negatives cancel. I'm going to write that as a +2. And now we're just solving for y because we're going to go to slope-intercept form. So this is y minus 5. Distributive property gives us -3x minus 6. Add 5 to the other side. Y is equal to -3x minus 1. Checkpoint 5, go ahead and pause the video. See if you can do A and B using point slope form. Then come back and check your answers. All right, college algebra kids, let's see what we got here. So we have, again, here's our x, our y, and our m. So y minus y1. The hardest part is to get the right number in here. It's always the second number. So y minus y1 is the 5, is equal to the slope, which is 2/3 times x minus 3. So there's plugging in our pieces. We want to use distributive property first. This is y minus 5 equals 2/3 x minus 2/3 times 3. The 3's cancel, leaving -2. Last thing we want to do is add 5 to both sides. So y is 2/3 x plus 3. Letter B, same thing. We're going to plug in our pieces. Remember, this is x, y. Our slope is now 0. This is y minus 12 equals the slope of 0 times x minus 5. Well, what's 0 times anything? That's 0. So y minus 12 equals 0. Just add 12 to both sides. Y is 12. So there's our horizontal equation, y equals 12. So there's practice with equations of lines. We're going to do this as part 1. In the next video, we'll look at part 2. Your homework is page 177, 8 through 42 evens, 48 through 54 evens. Have a good day, college algebra kids. See you in class.